Okay, good morning then, everyone. So welcome to A-Level Revision Sheet 7. This one's on coordinate geometry, so circles and straight lines. I've got 2 examples, and then there are 6 questions on the sheet, and then obviously the extra exam questions to do as well. So let's make a start with looking at the key points. So I've put in the y minus y1 equals m brackets x minus x1 formula for the equation of a straight line. This is probably the easiest equation to use and leads to the least mistakes in terms of exams. We also know that 2 lines are perpendicular if their gradients multiply together to give -1, i.e. one is the negative reciprocal of the other. I've not written it down, but also they are parallel. 2 straight lines are parallel if their gradients are the same. And then I've got the standard canonical form for a circle. Now this is not in the formula book, but we do need to know it. So in brackets, x minus a all squared plus in brackets y minus b all squared is r squared. That's a circle with centre AB, radius r. And then these 3 are kind of the 3 main circle theorems that you need to know for A-level. That's tangents to a circle meet the radius at 90 degrees. The radius perpendicularly bisects a chord of a circle, and if AB is the diameter of a circle, P lies on the circumference, then the angle APB, that should say, is 90 degrees. So that's the one where if you've got a circle, you've got a diameter, then in the triangle inside the semicircle, that's 90 degrees. The one about the radius perpendicularly bisecting is if you've got a circle, got the centre, got a chord of a circle, then if the radius from the centre to the edge passing through the chord meet, then it meets at 90 and it splits those into 2 equal lengths. Okay, let's make a start on the examples. So example 1. I've got a circle. I want to find the centre and the radius of that circle. Right, so to do this, we always start by completing the square. So I start by completing the square just on the first 2 x terms. So we've got x minus 2 squared, then minus 4. Now I complete the square on my 2 y terms. And then I rearrange into canonical form, so all the just numbers need to move to the other side of the equal sign. So we end up with x minus 2 squared plus y plus 4 squared equals 25, adding 25 to both sides. So this has centre 2, -4, and a radius of r equals 5. For part B, if I want to show a point lies on the circle, I just consider the left-hand side and substitute in. So at 6, -7, we end up with x minus 2 squared plus y plus 4 squared is equal to 6 minus 2 squared plus -7 plus 4 squared. Well, 6 minus 2 is 4, so we've got 4 squared plus 3 squared, which is equal to 5 squared, which equals 25. So P lies on the circle. Part C then. Got my circle. drop my centre to -4. That must be the point P. I'm finding this tangent here. So we're going to use our circle theorem property to say if I find the gradient of the line CP, I can find the gradient of my tangent. So the gradient of CP is change in y over change in x. So -7 minus -4 all over 6 take away 2. So -3/4. So the gradient of the tangent is the negative reciprocal of that, so m equals 4/3. And we're now going to use y minus y1 equals x minus x1 with the point 6, 7 and that gradient. So using y minus y1 to m times x minus x1, we have got y minus -7 is 4/3 times by x minus 6. And that rearranges to be y equals 4/3x minus 15. Or I could write that as 4x minus 3y equals 15. And that's the equation of the tangent. Okay, let's do the second example. So I've got 3 points. I'm told that they lie in a circle. I want to show you that RP is perpendicular to RQ. So if I find the gradient of RP and the gradient of RQ, they should multiply to give -1 if they're perpendicular. So let's work that out. So the gradient of RP, again, change in y over change in x. Eight minus -9. Just pause there. What mistake have I made? I've made a mistake there. What is it? Perfect, yeah. So if you spot change in y, I use one y coordinate and one x coordinate. So you've got to be really careful with that. So the change in y for RP is 8 minus 10 all over 5 minus -9. So that's -2 over 14, which is -1/7. Sorry. And now I can work out the gradient of RQ. Similarly, change in y over change in x. The gradient of RP times by the gradient of RQ is minus 1 over 7 times 7, which is equal to -1. So RP is perpendicular to RQ. Part B, this is to do with that circle theorem. So I've got my 3 points. R, P and Q. And I've just shown that this angle here is 90. Therefore, PQ must be the diameter, or a diameter of the circle. Okay. So PQ must be a diameter of that circle now. So now, part C, we're going to find the equation of that circle. So let's find the midpoint, because this will be the centre. So the midpoint of PQ is 5 plus minus 11 over 2, and 8 plus -4 over 2. -6 over 2. So -3, 2. So the centre of the circle is -3, 2. So centre of the circle so I'm going to call it C. So -3, 2. And then to get the radius, I'm going to find the distance from C to P, or the distance from C to P is a change in x, so 5 -3 squared plus 8 minus change in y. So go 8 squared. 6 squared, which is root 100, which is 10. So the equation of the circle is, because the centre's -3, 2, this is x plus 3 all squared plus y minus 2 squared and equals 10 squared, which is 100. There you have it. That's the equation of the circle. Okay, I hope they make sense. So good luck with the questions.